We're going to talk about congruence a little more, what it means and how to tell if two things are congruent. So when we talk about congruence, you can picture two congruent shapes as being like identical twins. They're going to be exactly the same shape and exactly the same size. It's like if you took one and you did copy and paste, and so you have two that are exactly the same. So we have some different examples. We've got some congruent segments, which is something we've looked at already. We can also have congruent two-dimensional shapes, like quadrilaterals or triangles. We can also have congruent three-dimensional objects, like these congruent prisms, or you could have some congruent cylinders. And so far, we've only dealt with congruent segments and angles. But I think when we look at these more complex shapes, it can help make the idea of congruence make a little bit more sense. Because we're saying same shape and same size. If we look at these congruent prisms, we can see that that's true. We can see not only are they the same size, but they're also the same shape. And it's pretty easy for me to picture a prism that would be a different shape. So let's picture one that's really differently shaped. You can see the ones that are there already, they're relatively shorter and wider, whereas I'm making this one much taller and more narrow. So we can see, yes, those are, between this one and this one, not only are they a different size, but they're also a totally different shape. We can also look at our quadrilaterals in the middle. These do look like they're just copied and pasted versions of each other. I can also picture, something like, we'll just pretend like this is an absolutely perfect square. Not only is it a different size, but it's a different shape. Or I could draw, a rectangle. It's not only a different size, it's also a different shape. Do our kind of classic shaped parallelogram too. Different shape, different size. So all of those extra ones I drew are not congruent to the ones that were there. When it comes to segments, I think it can seem kind of abstract and confusing when we talk about congruence because these two that are there, obviously they are the same size, or they look to be about the same size. But when we think, well, what do we mean by same shape? And it doesn't really make sense to talk about segments being the same shape because they're just this very simple one-dimensional shape. When you have two segments, they're either going to be the same length, or if they're different, they're going to be different lengths. Length is the only way they differ from each other. That's different from these two-dimensional objects where they can differ in both size and shape. These three-dimensional objects, they can differ in both size and shape. But with segments, they're only going to differ in length. So when we talk about congruence, what that means is for now it actually is very simple. If we are talking about congruent segments, you don't have to worry about the shape part. Just know that that means if they're congruent, they're the same length. If two segments are not congruent, then that means they are not the same length. So let's talk a little bit more about congruent segments to start. So as we just said, if two segments are congruent, then they have the same length. And that's the big idea that we want you to take away from the congruence lesson in Unit 1. Another way to write the same exact thing, but in terms of these specific segments, I could say if segment WX, that's this one, is congruent to segment YZ, then the length of WX is equal to the length of YZ. So generally, when we have this little symbol above the name, this means I'm referring to the shape itself. I want to say, hey, look at this shape that's drawn here. If I've got just the letters and there's no bar above it, then this is referring to a measurement. It's referring to a number. So I'm talking the length of WX, some number, is going to be equal to the length of YZ, which is also some number. So for example, if I know these two are congruent, in this case, I've got a statement right here in sentence form, and I've also got these matching hash marks. So even if I didn't have this sentence here, I can still see, oh, they both have one hash mark. So that's a matching number of hash marks. That means they're congruent and have the same length. So for example, if one is 6, the other one is 6. If one of them's 5, the other one's going to be 5, etc. I could also, as we just saw, so I could just have two segments. I don't have any points labeled. I don't have their names. I don't have a sentence describing if they're congruent. But anytime you see two segments in an image in any way, and they've got a matching number of hash marks, in this case, these two segments, they're both labeled with 2 hash marks. That tells me they're congruent. And being congruent, that tells me they have the same length. So for example, if one of them's 10, maybe you get a problem where one of them is labeled with the length, the other one has the same number of hash marks, but you're not given the length. That's where you come in with your knowledge of congruence and say, oh, well, I know the other one must be 10 also. And that might be a really critical clue to solving that problem. Now, on the other hand, we can take this statement and we can flip it around. So here we're saying if they're congruent, then they're the same length. But I can flip it and say it backwards. I can say if they have the same length, then they're congruent. That is also true. So if I see a situation like this, I can say, well, these two segments, I don't see anything, any sentence about them being congruent. I don't see any hash marks, but I see that they're the same length. That tells me that they're congruent. So another way to write that would be if their lengths are equal. If the length of AB, which is 3, is equal to the length of CD, which is 3, then I know segment AB is congruent to segment CD. So we just want you to know that this is true in both directions. This idea is probably going to be what you use a lot more in this class. We really want you to be on the lookout for any time you see these matching hash marks and know that that tells you that the numbers, the lengths, are going to be equal. This idea is probably going to be more limited to our congruence unit, but it's still good to know. You just know that this statement is true both ways. And just as a little fun aside, these two statements, we would say these are the converse of each other. If you take a statement like this and you flip it around and say it backwards, that's called the converse. And a lot of statements, they're not necessarily true both ways. You can say it forwards and it's true, but you say it backwards and it's no longer true. This one happens to be true when stated both ways. That's called a biconditional statement. That's something we're going to get into in our logic and reasoning unit, just as a little sneak preview. So this is all about segments. Let's look at congruent angles. And then we're going to do one little example to try to spot all of the congruent angles and segments in a problem, and then we'll be done. So very similarly to segments, if two angles are congruent, then they have the same measure. So written out in algebraic or equation form, it would look like this. If angle A is congruent to angle B, then the measure of angle A, this refers to a number of degrees, is going to be equal to the measure of angle B. And just like with segments, we can state the converse. We can flip this sentence around backwards, and it's still going to be true. If two angles have the same measure, then we know they're congruent. So if we see one angle is a certain number of degrees, and that's equal to another angle, it's the same number of degrees, then we know that those two angles are congruent. And similarly, we have this differing form of notation where when I just have this angle, I'm referring to the angle itself. I want to refer to the shape that we're looking at or we're talking about. When we put the M there, this represents a number. This represents some number of degrees. Now, you could have a statement in a problem where it just straight up tells you two angles are congruent. You also may be responsible for looking at an image and determining that two angles are congruent based on the little symbols in the image. So I want to go over the different ways that we might see that. One way is that if you see two angles in a problem and they have this little curved arc here, and then there's a hash mark. It's very similar to our segments. If we've got an equal number of hash marks, then those two angles are congruent. So we know they're congruent, and thus we know they have an equal measure. So you might see an image where it's giving you just this information, these symbols, but then the problem might tell you that this angle is 30 degrees. It's up to you to figure out, okay, that means this angle is also 30 degrees. And again, that might be a really critical piece of the puzzle to solve that problem. You also can see angles where they have a different number of arcs. So they might not have any hash marks going on, but we can see in this angle, there's two little curved arcs. And in this other angle, there's the same number, two little curved arcs. That tells me that these two angles are congruent. That tells me that they have the same measure. And then kind of on the flip side, we could also see two angles where we are given the angle measure for both of them, and we see that it's the same exact number. That tells us that they're congruent. That's this idea where if the measures are equal, then the angles are congruent. And again, I think this idea where we show you the congruent symbols, and based on that, you have to know that these angles are the same measure. You're going to use that a lot more. This is one that you're probably going to use quite a bit in our congruence unit and less so outside of that unit. But either way, it's true in both directions. If you know they're congruent, then they've got the same measure. If you know they've got the same measure, then you know they're congruent. And angles can also be a difficult thing to picture congruence with because, again, they're such a simple shape. It's not like when we have, you know, two triangles. We're going to have a whole unit talking about triangle congruence. Well, I can have, you know, this really squat, wide triangle, or I can have this really tall, narrow triangle. I can have a right triangle, all sorts of things. And we can tell, oh yeah, those are all totally different shapes. With angles, it's again, we're not focusing on anything to do with shape. We're just talking about the angle measure. When we talk about two angles being congruent, all you have to know is that they're the same measure. And some students can get confused if, say, you know, I've got this angle that looks like this, and I've got this angle that looks like this. Okay, if they have, let's use our little example where there's a little arc and then there's a hash mark. If they've got the same number of hash marks, those two, then those two angles I just drew are congruent. Let's say this one is 80 degrees, then that means this one is 80 degrees. And the length that you see, these arms of the angle, the arms or sides of the angle, that does not matter at all how long those arms look. You'll also see angles, you know, in triangles, like this angle here, okay, this angle here, this angle here. And so sometimes the sides of the angle, they're not even drawn as rays, they're drawn as these finite segments. So anyway, it's just the measurement. It's just the measurement in degrees that we care about. Okay, and so just a little example, just for us to practice this. I want to identify the congruent angles we see and the congruent segments. So this is something that looks like something we might see in our triangle congruence unit. I know it looks fun. For now, we're not really doing a particular problem. I just want to find all of the congruent segments. So if I look at the sides, I can see that this side and this side, they both have one hash mark. So I know that those two sides of those two triangles, I know that whatever length they are, it's the same length in both of them. That's what those hash marks tell me. I can also see that this side has got two hash marks, and this side has got two hash marks. They're exactly the same. Whatever the length of one is exactly the same as the length of the other. And it looks like there's one more set of congruent segments here. That side of that triangle and this side of this triangle, those are also the same because they both have three hash marks. I don't think I mentioned that. So the orange ones, they both have two hash marks. That's how I know they're congruent. The yellow ones have one hash mark. That's how I know they're congruent. And if we look at the angles, maybe I'll switch to a pen here. I can see this one has just one. Actually, I shouldn't do that because I don't want to cover it up. Let's use a highlighter instead. It's getting a little crowded in here, but we'll try our best. So let's try purple. So this one has one little curved arc, and so does this angle over here. I know that's kind of sorry, I'm having a hard time making decisions about the color choice, but I want to make sure it's visible. I think I'll go back to yellow. All right, so this one, okay, I'm trying to highlight it in yellow, has only one curved arc, so I know that those two angles are congruent. So if one of them's 50 degrees, the other one has to be 50 degrees. I also see a pair right here. There's two little arcs, so I know that those two angles are congruent. Maybe they're both 95 degrees, something. Whatever one is, so is the other. And actually, it's pretty exciting. There's one more pair of congruent angles here. I'll give you a moment to try to find them. Did you find the last pair of congruent angles? There's only one more pair of angles we can look at here. I hope you saw that these two angles in the middle are vertical angles, right? We've got two lines intersecting. I'm saying lines. These are obviously line segments because they're part of a triangle, but we often just say two lines intersecting. And so those angles on opposite sides of the intersection are congruent. Now, I don't want to mix up, okay, this angle has one arc and this angle, I've only drawn one arc in, but I don't want to say that these two are congruent because I don't know that they are. I just know that these two in the middle are. So I'm going to use a different number of arcs. I'm going to draw in 3 arcs. So 3 arcs here and 3 arcs here. That tells me that that pair of vertical angles, well, it's kind of redundant. I already knew that they were congruent because they were vertical angles, and now I've just marked them up redundantly to show that they're congruent. All right, I hope that helps a little bit with this idea of congruence. It's one that we're going to be using a lot in all sorts of different contexts throughout this whole year. So if you still have questions, if you want to do more problems where we find the different pairs of congruent segments and angles, maybe we use that to determine missing angles or missing links, we can do that in a help session. Just email me and let me know. All right. If you have any questions about anything, email myself or Mr. Small.